Well, welcome back, ladies and gentlemen, here on Tuesday, lesson 2 of the rational root theorem, which is basically, excuse me, a little bit more practice than we had the day prior. So what we're going to do is move along. Your tasks for today, the rest of the week. Today we're going to finish this up. You're going to complete 5.5 day 2, which is a whole conglomeration, okay? Some of those problems might factor right away. Some of them might not, to where you need to use the rational root theorem right away. And guess what? There's a test this coming Monday. Tomorrow, formative, and also answering questions on lesson 5.4 or 5.5. And if you have last-minute questions before you jump into your formative, hop on the chat. Mr. Myers and myself might be able to answer your question for you. And did you know, guess what? Test on Monday. And then Thursday, we're just going to review, workday in class, live for everybody. I encourage you to log on, ask questions if there's things you don't know. Mr. Myers, I think, might want you to stay on the whole time sometimes, and sometimes I do as well. So make sure you log on and you show your face in there, and you're going to work the whole time. And did you know there's a test on Monday? Friday is workday. Okay. So we're going to determine all the roots here. We're just going to pick up on number 3 where we let off. Determine all the roots for this function equals 0. We're going to determine all the roots, meaning find all the solutions, all of them. So in order to do that, because we have 5 terms, and I'm not lying when I say I don't know how to factor a 5-term polynomial. Ask Mr. Myers if he does. He might. I know there's a way to do it, and if he does, I'd love to learn. I don't know. So in order to determine the possible roots, we need our P's and our Q's. Watch your P's and Q's, okay? So what we need to do is we need factors of 36, and we need to divide that by factors of 2. Well, I look at it as a big, ugly fraction. I look at it as 1 times 36. Those are factors. 2 times 18 gives me 36. 3 times 12 gives me 36. 4 times 9 gives me 36. And I know 6 times 6 gives me 36. So those are all my factors of 36. And I got 1 times 2 gives me 2. So my possible roots are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. I just paired up that 1 with everybody on the top. Remember, it's plus or minus of everything. Now I paired up the 1. Now I got to pair up to 2. So I say plus or minus 1/2. 2 over 2 is 1, which is in my list. 3 over 2 is not, so plus or minus 3 over 2. 4 over 2 is 2. 6 over 2 is 3. 9 over 2 is 4.5. That's not in there, so plus or minus 9 over 2. 12 over 2 is 6. 18 over 2 would be 9. 36 over 2 is 18. Look at that. Does that make you feel better? Okay, we need to guess and check. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 possibilities. Doesn't that make you feel good? So, where do we start? I don't know. What I do to start is I usually take all my positives and write them down. 1, 2, 3, 4, 6, 9, 12, 18, 36, 1/2, 3/2, 9/2. I like the positive numbers before the negative numbers. It's just the way I do it. Everybody's going to pick their own way to do it. And I'm going to set up my synthetic division of 2. I don't need a comment. I got to set her up. So I got 2. I got 7, negative 22, negative 63. And I'm going to have to move those. Am I going to be able to do this? I am. I'm going to impress myself. Grasshopper. And I got a 36 here. And what I'm going to do is I mentally do positives. These are only my positives that I'm looking at right now. And like I said yesterday, if I add these up, if I add the coefficients 2, 7, negative 22, negative 63, and 36, if they add up and equal 0, 1 is a rational root. But I can see I only have, what do I have, 45 positives and about 85 negatives. So I know 1 is not going to work. So I'm going to try 2. Okay? And there's no special. That's the only little trick I know in here is with positive 1, add the coefficients. So then I'm going to drop down my 2 and say 2 times 2 is 4, plus 7 is 11, times 2 is 22, gives me a 0, times 0 gives me a negative 63. Obviously, negative 63 times 2, that's what, negative 125. Ain't no way that's going to be 0 right here, and that's what we need. So that means 2 doesn't work. Get out your eraser, and you're going to erase, or you're going to start up a whole new synthetic division, and we're going to get rid of those. And notice how I crossed off. These are my positive 2's. Then, you guessed it, now I'm going to try 3. 2 times 3 is 6. Plus 7 is 13. Times 3 is 39. Plus negative 22 gives me 17. Times 3 gives me 51. Plus negative 63. Ooh, look at that. Gives me negative 12. Times 3 gives me negative 36. Bingo, I got one. Woo-hoo! Okay, so I'm going to kind of look at this, and I'm going to rewrite the polynomial as a product, and I'm going to do this. You don't have to follow all these A, B, C, and D's like that, but I know I just factored the first step, and it's going to be x minus 3 times 2x to the third plus 13x squared plus 17x minus 12. Okay, what I'm going to do is I'm going to try to factor this by grouping now. But see, I can look here. I can look at my numbers, and I can see there's nothing in common between 2 and 13, 17 and negative 12, which means it's not going to factor, because all I'm going to do is take an x squared out of here, and I'm going to be left with a 2x plus 13. And over here, all I'm going to be able to do is maybe take out a negative 1, but that's going to give me a negative 17x plus 12. And what I'm seeing is I'm never going to get these parentheses the same, so I know factoring by grouping is not going to work. So I'm off to the races again. All right? Now, what I want to do, again, is I want to factor this guy. And notice my P and my Q kind of changed, okay? So what I'm going to do is I'm going to list my possible rational roots. I'm going to do my P's over Q's for my new one because I have fewer of 12 over my 2. So this is going to be 1, 12, 2, 6, 3, and 4 over 1 times 2. Okay? So basically what it's doing is if I look at my new P's and Q's, I'm really kind of shortening that original list I had. All right? So I'm really kind of just looking at plus or minus 1, 2, 3, 4, 6, 12, a half, 3 halves, and that's it. So now I just kind of short them down. So I got 1, 2, 3, 4, 5, 6, all the way up to 1, 2, 3, 4, 6, 12. 1 over 2 is a half, 2 over 2 is 1, so that's in there. 3 over 2 is 1.5, 4 over 2 is 2, 6 over 2 is 3, 12 over 2 is 6. Those are in the list already. And now the beautiful thing of this, guys, is from the beginning, 1 and 2 never worked. They're never going to work. 1 and 2 are never going to work, okay? So now what I would encourage you to do is, you never know if you have a double root. I would take the 2, the 13, the 17, and the negative 12, and I would see, does 3 come out again? Because if it did, it's very possible it could be a double root. So I'm going to drop it, and that gives me a 6. This gives me what? 19, which gives me 757, which obviously this isn't going to work, but, okay, 57, that's 4, that's 74, and 3 times 74 is 12, is 222, and that gives me 210, right? So 3 gave me a big number, but what you really want to focus on here, all are positive numbers, okay? So if I tried 4 up here, these numbers down here are just going to get bigger and faster. That means it's upward bound. So that means 3 is not going to work anymore. Any positive number, any number bigger than 3 will not work. So I can throw out 4, 6, and 12. They're not going to work because I've just ruled them out. But notice, a half and 3/2 are smaller than 3, as are all of my negative factors that I could try too, all my negative possibilities. I am a guy, because I'm a sign dropper, I always try my positives first. Okay, so now what I'm going to do is I'm going to set this up. And what am I going to do? Get a smaller eraser. I'll keep the bigger one. And I'm going to truck this out like so. And I'm going to get rid of my 3. And I like to eliminate, this is a personal preference, all of my positives first. So now I'm going to try a half. I know everybody's afraid of fractions, but you don't need to be afraid of fractions. So if I drop a 2, what's a half times 2? It's 1. Plus 13 is 14. What's 1/2 times 14? It'd be 7. Plus 17 gives me 24. Don't be afraid of fractions. 24 times a half is 12. Ah, I found it. Okay, I found it. And notice I'm not following these rules. I'm just kind of zippity-doo-dying because I did these all in this next step up here. So what have I found? What I have found is I have taken this dirty dog now, and now it's looking like x minus 3. Hey, if my factor's a half, wouldn't that look like x minus 1/2, right? And then what's left is 2x squared plus 14x plus 24. You do not want to guess and check anymore, guys, because this guy is quadratic. And you know how to factor quadratics. You're all masters of quadratic factoring. So what you would do is you would take this guy down. Hopefully you notice there's a GCF in here now of 2 that you can take out. And that's going to be an x squared plus a 7x plus 12. Okay? Which means, does this factor? Well, x in an x, both signs have to be plus. Factors of 12, how about 4 and 3? Give me 7. So I can rewrite the original. I just completely factored this thing. Okay? I've rewritten it as x minus 3 times x minus 1/2 times 2 times x plus 4 times x plus 3. Okay? Now watch this little slippity trick. Nobody likes this factor. But check out this 2. If I distributed the 2, I can multiply 2 to any one of these factors, but I would probably like it there because then I'm going to have an x minus 3 times 2 times x is 2x minus 2 times negative 1/2 is 1. Ooh, check it out. Remember when I said that negative half looks like that factor? It absorbed that 2, and I get an x plus 4 and an x plus 3, and I have completely rewritten the original polynomial as a product. And if I say it equals 0, now if I want to determine all the roots, okay, I've just done I right here. And do they want us to identify? If they wanted us to identify, did they want us to write and solve? Determine all the roots. So yeah, they want to know what x equals to be an x-intercept. So all my roots, check it out. X is going to equal 3. This one, x, 2x minus 1 equals 0. So 2x still equals 1. X is still that 1/2 it was before. And I have x minus 4. And I have x minus, or equals, why did I do that? Because I'm trying to make your video shorter. But this is, did it again. This is x equals negative 4. And this is x equals negative 3. So what are all my roots? 3, negative 3, negative 4, and positive 1/2. Those are all the roots. Well, check it out. In the beginning, we knew this was going to have 4 roots to it, didn't we? Due to the fundamental theorem of algebra. And it just so happens to be they are all real in this case. All right? Sweet deal. Woo-woo. Yay. And check for your understanding here. Let's check it. Let's see if you really get what's going on. Determine the zeros of this function. Determine the zeros. And we want real and imaginary if they have it. Determine all solutions. Well, check it out. What do we know? I don't want to do my P and Q thing on this because they gave me a graph, and I can see it sure looks like negative 6 is an x-intercept, doesn't it? So I'm going to try to synthetically divide out because I don't need my P's and Q's yet. And if I put my negative 6 here, 1, negative 6 gives me a 5, gives me a negative 30, gives me a 7, gives me a negative 42 for a 0. Woo-hoo. So I know x equals negative 6 is a 0, right? Because this means x plus 6 is a factor, which means x equals negative 6 is a 0. And I'm left over with x squared plus 5x plus 7. And I want to find out how that dirty little dog equals 0. And so I would try to factor it. But if I really look at that quick, there ain't no way that's going to factor. Are there 2 same signed numbers that multiply to give me 7 that are going to add to give me positive 5? Nope. So what are we going to do? We're going to have to say x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, which is going to give me negative 5 plus or minus the square root of 25 minus 4 times 1 times 7, that'd be 28 over 2, which means negative 5 plus or minus the square root of negative 3 over 2. So my other 2 solutions are x equals negative 5 plus or minus, pull out your eyes, guys. 2. There's 2 imaginary, and there's 1 real. And our original function tells us we needed 3. Woo-hoo! Okay, last one. I know this is not in your note sheet, but give it a try. Determine all the roots for this. Don't fall into the trap of, oh, I got to do P's and Q's, I got to do P's and Q's. This is quadratic form, ladies and gentlemen, which means it just might factor nicely. Meaning, x squared times x squared gives me x to the fourth. One's got to be plus, one's got to be minus because of that sign. And, ooh, how about 9 negatives and 2 positives, because that's going to give me negative 9. Negative 9x squared plus 2x squared gives me negative 7x squared. Woo-hoo! Got it. Okay? And if you notice, I can keep on a pumping. These are both quadratic now. Difference of squares. X plus 3, x minus 3. Not a difference of squares. So that one stays there. What are all my roots? I got x equals negative 3. I've got x equals positive 3. And here I got x squared plus 2 equals 0. 1x, so x squared equals negative 2. I will square root that. So x equals plus and minus square root negative 2, which means x actually equals plus or minus I square root of 2. There's 2 imaginaries, 1, 2 reals, total of 4. How many did I have to have? 4. Yee-hoo! Got it. And you're off to the races for the rest of the day. Please let myself or Mr. Myers know if you have questions that we can work out with you. Have a good day.